All right, welcome everyone. Today we're presenting the final presentations of the AI for Eagles challenge. Over the last 12 weeks now, we worked very hard on various interesting parts of the project, from building AI models to classify the age of eagles, to creating a labeling app for experts to label more age classes of these eagles, to the final application that actually runs the models that we trained. Um, just a heads up, there is still some work in progress. So the models that we've trained that are running in the app right now should improve over time as we get more and more images of eagles labeled with the right age classes. I'm gonna start sharing my screen. All right, so welcome everyone. I think I saw everyone in chat already knows Fruit Punch, but I'll give a general introduction. We organized this challenge together with the SLU, together with Nav and their researchers from the Swedish University of Agriculture. And special thanks to Cornell, the Lab of Ornithology, for lending us their data in order to train the models for this challenge. Today I'll do the introduction, give you a short, brief introduction on the data set as well. Then Anne, Azukena, and Pascal will talk about the AI models that we've trained. And finally, Prasad, Rizdi, and Sunny will be talking about the labeling application and the classification application that we built. Finally, in Avner, I've scheduled some time for you to give some final words, and then we can round it up. So for today, we are Fruit Punch AI. We are a global AI for Good community. And we started this community because we believe that to solve humanity's greatest challenges, we need to educate AI engineers at scale with an ethical and sustainable mindset. So we do this by organizing AI for Good challenges. And we define AI for Good challenges by any challenge you can relate to one of the Sustainable Development Goals. That's why we organize challenges in the wildlife space, but also in the energy transition, climate change, anything you can relate to the Sustainable Development Goals, and you have a data set in, we can build a challenge on. These challenges are a great way to learn AI in practice and in a peer-to-peer manner with people from over the entire world. You can start working on AI and get your hands dirty with some real-world data. For today, we're going to be talking about the AI for Eagles challenge. And we came up with this challenge together with Navinder because there are some problems with automating eagle classification. The reason why we need to automate eagle classification is because eagle monitoring is a very heinous task. It can be very difficult to monitor eagles' age with the untrained eye, especially for people who don't have a lot of experience with eagle classification. To be specific, in this challenge, we've started with the basic eagle species classification, and then we went on into finally classifying the age as well. The reason why this is important is because if you have a better approximation of how old the eagles are that are in your image, you can do better predictions of how well the population of eagles is doing. And since eagles are a key species in their ecosystem, they are also an indicator of how well the entire habitat is thriving. So the entire ecosystem, for the entire ecosystem, it is a nice key species to check whether to see if the entire ecosystem is doing well. To automate this, there are a couple of problems. First one is it's very difficult for an untrained eye to see which age an eagle is. Then there are some other troubles, like often the images of these eagles are for very far away. So it's difficult to find the right features which you can use to classify the age. And to solve this problem, we wanted to create a central point where a lot of researchers can upload their data and classify the age of these birds. Therefore, we built a labeling app as well as a classification app. And we did this to hopefully speed up the process of classification and labeling a lot. As I said, over the last, it should be 12 weeks already. Over the last 12 weeks, we worked with two groups. Originally, it was a data engineering group and a model builder group. But as I said, there came a lot of hurdles on the road along the way. So we switched up the teams a bit, but we ended up with 12 AI for Good engineers, and we put in approximately 1,200 hours of engineering work. So kudos for that. Great work, guys. And our goal was exactly to classify the species and age of golden and white-tailed eagles to monitor their population health and the ecosystem. Yeah, we started this challenge on the 12th of June. And I also forgot to adjust this date. I'm sorry about that. But we're finishing it up today on the 24th of October. The team members will still have a week to finalize their reports and their code. So next week we'll have a final deadline for the team to deliver all their work. Yeah, so what is the data set we're working with? We got, as I already said, a nice data set from eBird. eBird is a very large catalog where bird watchers, bird lovers can upload their images, and they also label them, but there's not too much checking going on there. So the labels from the eBird data set need to be taken with a grain of salt. So we have flying, sitting, eating, and mixed eagles, and our 7,000 images exist of around 56,000 of golden eagles and 14,000 of white-tailed eagles. So quite a large data set, which we could have done quite some processing on. I think Anna also has some nice things to say about that during his part of the presentation. But to give you an idea of what the data set looks like, here are some images that we were working with. Some you can maybe already see are very clear. This might also be a nice one to tell for the people who haven't been joining the challenge and are here to watch. To classify the age of an eagle, you have to look at the colors under the wings. So for images like this one over here, can you see my mouse? I hope so. You can see that the white spots in the feathers are pretty bright, which indicates that this is a younger bird. When the white spots are less visible, it indicates that the bird is older, and in that way we can classify their age. As you can already see, some images in the data set are very blurry. That's because they were taken from super far away. So that's one of the hurdles that we had to overcome in this challenge. But you will hear more from that from our participants. I think we can get started with the modeling teams. So I believe that Anne will kick it off here. Anne was working on the eagle species classifier. So he mainly focused on classifying whether it's a golden eagle, a white-tailed eagle, or something else like a plane or another type of bird, or Superman for that matter. So Anne, I will give you the screen now.
Since I also use the cropped image of object detection, so I'm gonna let Azukena to talk first.
Oh, all right.
Okay, so my name is Azucena, and I'm working in the modeling part. And the first thing that we did is the in-flight detector, and the data that we use for this is coming from the eBird, but we only using the reviewed images. For both species, we annotated 900 from the white-tailed eagles and 4,200 annotated image from the golden eagles. But for the modeling, we are only using the golden eagles. And the modeling part for the in-flight detector is we have the whole image, as you can see in the left. Then we pass this to the YOLO V8 model that we trained. And at the end, what we will have is the cropped image of the eagle and also saying the status, if it's flying or if it's sitting. So as I mentioned before, this was trained on images with bounding boxes that were annotated by us. And we also tagged if it was sitting or flying. So the sub-goals of this one was to get the flying status as well as to extract the cropped images from the eagles. These are the results from the modeling part. So as you can see, we got a good average precision. And I'm gonna now then go to, I guess another thing to note here is that this one, it's better for the flying status than the sitting status. And this is like the one that we care the most. For the species classification, and we'll talk about it.
So, yeah. So, I also did try to use just the reviewed image, but it caused like huge imbalanced data problem. So, as we have talked about, that's why I use both reviewed and unreviewed. And this is a significantly harder task. That's why it's worth like a lot more hefty chunk of data. The data set was clean, remove of empty erroneous files, a lot of images of anything that's not a real bird. Yeah, both full and cropped images were used to classify both species. Yeah, and also with and without augmentations, with two types of model, one that is small and light and really fast to train, so it's faster to iterate between experiments, like MobileNet V2, and then a large one finally, which give us a final boost. And unsurprisingly, training with balanced crop data on a larger model and augmentations give better results. Yeah, and this is the results that that we have talked about. It's all reached more than 9x on both species. I know Dorian did say that there was going to be a third class of nothing, but due to time constraints, we did not manage to get there. But definitely, like it is a valuable if we don't have like a model to identify an eagle beforehand. Yeah, and yeah, so this is how you would differentiate between two eagles. And I do believe like there's also a trait that can be used to differentiate using the wings, right? And as you can see here, the model has learned like where to look at when you look at an eagle, cropped image of an eagle. And yeah, like there's a lot of nuance here because it differs with age, but as long as you give them tens of thousands of images, I think they can find where to look at. And that's about it.
Okay, so for the age classifier, we use annotations that were done manually in an Excel file, and also in an automated way using a labeling app that will be explained later. And like I think it was the last CSV file was updated 2 weeks ago. Unfortunately, we weren't able to update it now, but at that time we had 495 annotated images. And I just want to clarify that 380 were annotated by non-experts because this is important for the quality of the annotation. And here you can see the different age categories that we have, and also like the number of annotations that we have from each of the categories. So as you can see, it's like really imbalanced, and basically we have all of our like the half of it is coming from the 5+ category, and we barely have anything coming from 1 to 2, and yeah, the rest is kind of even. So this is the data that we have for the age classifier. Since we didn't have a lot of data at that moment, what we tried here is to use two-steps modeling, and we are going to use the embeddings from Dino V2. And these embeddings come from the crop images that the in-flight detector is providing us. Then after that, we have the embeddings. So the second step here is to train an SVM model, and this will classify the age category. So as I mentioned, it was trained on the crop images, and here we actually did 2 sub-goals, because we also tried this modeling not only for the age category, but also for the flying status. But here I'm only going to talk about the age category results. So unfortunately, we didn't have such great results with the age classifier, but this is again something that it can be improved if more data, like more annotated images are provided. I think it will be better. And also, as Amy mentioned, if we add other features that are not only the image, it could improve the results. And I think that's all from the modeling part. Not sure who is next, but I will stop sharing.
Thank you, Azucena. Yeah, as I already mentioned, so the number of images should greatly improve the age classifier still. So that's definitely something we will still be interested in how that further goes.
Yeah. Okay. So actually, I have to reload it for the first. So just to give a better start. So actually, I and Tom Good developed it so much far about this library application, but I think that Tom acquired much more credit than I in to gather logics behind this labeling app. So, but since Tom is still on the holiday, but I have just to give presentation on this labeling. Oh, no worries. Okay, so to begin, we enter as a labeler. Let's put a call my name. So I expect that my expectation to expertise is pretty much low, so I just pick low. And you have an option whether to give a new label to the birds, or there might be some images that the images has been labeled. So we would be the second labeler then. But in this case, let's just say that I will pick as a new labeler. So that means, no, please submit. All right. So here, as we can see, an image of bird appears on the page, and also the information about age and species and about the behaviors that a bird is currently existed in, and also the date of taken image and the uploaded image. And also the geographical sites about country, county, and state also informed here. And what we can give to label to the image of the bird is the age in which that we have the 0 to 1, 1 to 2, 2.5, and 5 plus. And we are also aware that there are also images that looks like sounds doesn't look like some many noises or blurs. So we have an option to remove the image from the collections for the later process. So since the image is very clear for us, the patterns is clearly visible. This is we choose 0 or 1 or 2. Yeah. And also we keep the image on, and yeah, we also have the option to leave the comment. Submit. And also, it seems to be a great day to me. And yep, the patterns is also visible, much more visible than previously. And we choose the maybe 0.1, 0 to 1 again, and retain the image. Submit. Yeah, this process can be repeated as much as we can. And yeah, but there's perhaps that one consideration for me. I think it is still remain a question whether it is possible to run the application in at the same time. It's like having 3 other labelers to the task at the very same time, but we have yet to reach the conclusion of the answers. But yeah, we'll have to get it somehow. And yeah, submit again. Yeah, I think this is the label application is intended for. And yeah, I think about okay, one more thing. We currently we see the much more blur image on this bird, and but the purpose is remains visible for us. Yeah, perhaps we just keep the image maybe, but with the comment image blurred. Yep. I think it is worse than before. Perhaps they have to remove the image then. Yeah. Okay. What becomes after we input the labels to the data set? So this labeling application automatically retains the information that we have input so far. It automatically saved into the file system that that we will take care about how to do next with the updated data. And yeah, on the site levels, I mean the sidebars that we put the functionality, I think it is intended for also. It is also intended for support, I think, to manipulate the image, like zooming or blurring. But I forgot to turn on the image enhancement. Yeah, here's the effect of the zoom. And if we zoom in or zoom out, yeah, so we can freely move the image as we would like to observe in specific areas, or maybe we would like to give much more blurring. The image is become much more blur. And about the brightness, yeah, I think it doesn't significantly alter meaning much for us. I mean, to help this image becomes much better, I think. But perhaps we can work on it later. Yeah, I think this is the presentation that I can provide to you for today. Well, I just expect some inputs or comments after this presentation finished. Thanks for all.
Thank you, Rizzi.
Yep. Number is.
Yeah, it really looks nice. I hope that all the birds were indeed 0 to 1 years old. Otherwise, we might need to go back and check the levels from you, Rizzi.
Yeah, exactly. And yeah, we just received some concerns that Pascal mentioned a few weeks ago about many rows that have that are labeled as adult appears as many as possible. So yeah, Tom was asked to not include the image which are labeled as adult.
Yeah, of course.
Yeah.
All right.
And and one more thing I forgot to mention. Emmy, yeah, I still working on the CSV that you provided to me a few days ago, and I think the image that you have provided is not difficult to be prepared on the FA Lab server. And yeah, just give me time to gather things out together in combination with the labeling app. But thank you, Emmy.
All right, thank you, Rizzi, for the demo. I want to clarify that the labeling app does not yet have the classifying models running in it. Therefore, we have built another app, and Prasad was the main driving force after that application. So Prasad, I would like to give you the opportunity to enlighten us on the application that you've built, as well as to see how well it works.
Yeah, sure, Dorian. First I'll go with the presentation, then I'll walk you through the app. Currently, I have made changes for the model inferencing page. Previously, it will accept a single image. Currently, it will accept multiple files. When user click on these browse files, he can select a multiple files to upload into this model inferencing app. And then it takes the files and it will generate the predictions. And all those predictions are being appended into consolidated into a CSV. So user can generate CSV and he can download that CSV file for his reference. Anyhow, if we generate the CSV, it will be saved in our local database as well. And after generating the CSV, user can go to the analysis of generated predictions page. Here, we'll use the previously generated CSV file, which has the image information. Just a second, I'll open that CSV. Yeah, this result CSV looks like this. It has a image file name and behavior, species information, and age information. Actually, it's 2-5. Due to the date format, formatting, it is displayed like that. Leave it, let it be. Okay. Actually, this CSV is being consumed in this analysis page. So it displays the images, and when a user can go through these images, I mean, he can see the predictions here and as well as here also. I mean, I need to work around this. I mean, how to display these predictions effectively. Yeah, well, a user can see the images and the prediction. So whenever user thinks that prediction is not correct, or there is some feedback that user wants to share, he can click this no button and he can write his suggestion like this. And it will also get appended into the CSV. Yeah, and at the end he can generate the CSV and he can download the CSV. That generated CSV looks like this. Okay, and I'll go through the app. This is the app that I am building. It's 90% done, and 10% I need to work on few things. Actually, it will take some time to run all the predictions. It is a measured prediction file that Tom has given to me. I implemented the same. So once the inferencing is done, we can go for generated CSV. Actually, I'm running this app since morning, so my tab is slow. Yeah, it's done. Yeah, I'll show you how it looks like. I have uploaded 3 images, and in the age, I mean, it is due to a formatting issue. It is 2 to 5. So these are the file names and behaviors, PC and age. And once we are done with it, we can go to the analysis page. Yeah. Here, user can navigate to the next image, and he can provide his feedback. There are some issues, bugs I need to fix it with the session variables that I'm working on. Yeah, here. This is the thing I have made so far. I mean, I had to make some modification and some bugs I need to resolve. So I'll take some time to finish this and make a good shape. So I'd like to hear suggestions to this. I'll work accordingly.
Thank you, Prasad. I think functionality-wise, it looks really nice. I think everything is in there that you need to quickly go through a lot of images. I do have a question. Like, what is the inference time for, let's say, one image? Do you know by any chance?
Yeah, it's nearly 2 seconds, I guess. I mean, while I'm working with it, I've seen that. But I'm not sure. I'll update over the Slack channel.
Okay.
Yeah, but definitely it is taking more time for inferencing. We'll
But I
see.
think 2 seconds is reasonable, I guess.
Mhm.
It's a lot faster than any human could do it in any way. Yeah, nice. Yeah, UI-wise, I'd say there are still some improvements to be made, but I think functionality-wise, we're pretty far. So good job, Prasad. I know you spend a lot of time working on it, so I think you can be proud of yourself. Yeah, I think we're pretty much through the presentations. I want to give Navin the final word, but before we go there, I really want to thank everyone for the hours you've put in. Really appreciate how hard you work on it, and I've seen a lot of great efforts throughout the entire challenge. We of course started with a bit of a different problem that we ended up to solve, because initially building a labeling app wasn't even in the scope of it. But I think by adapting and finding the hurdles that we saw and overcoming them, I think we have created a very nice and successful challenge. There's still some final edits to be made, but yeah, we still have a week left, and we also still need to transfer the labeling app and the modeling app to the servers from SLU. So I will be bothering some of you still over the upcoming weeks for a bit. So I hope that's fine with you guys. But I really want to thank you all for all the hard work, and just know that it's really appreciated. So yeah, Navener.
Thank you, guys. This has been so amazing. This is something I would say I couldn't have dreamt of, that we could pull this off in such a time we had. And thank you all who have volunteered from all over. I don't know, I have no words. I'm just still shocked by how far we've come through. Yeah, in some way I'm in debt of all of you, because we can take this so much further now with your initial push. And I would love to hear if you all still want to continue working, with us on more projects. And we have lots of more ideas. And also, we could also think about possibilities to pay for your time in near future, because I understand that you've been putting all of this on your free time. So I'll be very happy. This field is really growing fast, and there's, I don't know, infinite avenues for skills that you all have. And Amy went with us to the field, and she was laughing at our abilities to collect data and store and manage. So she thought that our life could be so much improved if we do things some other way. And she worked out such a easy way to download new data from the Swedish servers as well, so swiftly, which we didn't really know we could have done that so easily earlier. So thanks to you all again, for showing us these new ways to handle, and overall, like the total challenge that you're all dealing with, AI for good. I think this can really speed up, as you say, Dorian, in the sustainable development goals, in meeting conservation objectives, in many of these large global challenges. So I'm really proud of this work that you have put in, and yeah, I think it will take some time to sink in. And once we start to use this in every day and train these models more, we really realized when we sat down to labeling later in the evenings, even 3 or 4 of us, suddenly our abilities declined over the more images we did. We started to question each other more and more. Are we really any good? when we started to discuss these images. So our expertise declined from expert to moderate to low very quickly. So you really showed us that actually it's not that easy.
That's also a nice insight, I guess, or a very realistic, or you realize all of a sudden. But thank you, Navener. If ever in near future I happen to find myself somewhere in Sweden, I still love to come up to offer to go bird watching someday.
Any of you, all of you are welcome. You're part of the team now, so you're all welcome to be in
that's
touch.
sweet.
Yeah.
All right. Thank you, Navener, for these kind words, and I think that's
Thank
a
you all
nice
for the work you put in.
Final say for today. I'll be in touch with you guys, because we're still going to fill in some peer reviews. You will all receive a nice certificate from joining the challenge and putting in all the hard work. So I'll be in touch. But for now, I'm on holiday, so I will be in touch somewhere next week. I hope you all enjoyed the challenge as much as we did, and I hope to see you in future challenges as well. So have a very good day, and I'll talk to you on Slack.
You too. Let's keep the Slack channel going. Yes.
Definitely.
Okay. Bye-bye. Thanks.
Bye, guys.
Danke.
Bye-bye.
Thank you.
Danke.
Bye, y'all.